It says here at summer solstice. It's actually valid any time after the vernal equinox and before autumnal equinox. Right? Here is directly east. So after the vernal equinox, the sun rises directly east and sets directly west. And the sun is on celestial equator. But after the vernal equinox, the sun is rising north of east and setting north of west. More and more every day after the vernal equinox up until so-called summer solstice, when the sun is highest in the sky. Okay, so on the day of summer solstice, we have something like this. So here is the Earth. I'm going to draw a little bigger diagram because I want to point out a few more things. Here is, say, the North Pole, the South Pole, Earth's rotational axis. Here's the sunlight. This is the direction perpendicular to the ecliptic, and this angle now on the day of summer solstice is 23.5 degrees. And of course, this is equatorial plane. Now, the sunset line would be this line here. So this would be the illuminated half of the Earth, and this side here would be in dark. Now, what is the latitude of this point here that is on the sunset line, which divides daylight from darkness? If you know that this angle here is 90 degrees and that this angle here is 23.5 degrees, how big is this angle here? 66.5 degrees. So the circle on Earth with a latitude of 66.5 degrees is known as the Arctic Circle. So note that on that day, on this day of the summer solstice, all the points on the surface of the Earth with a latitude greater than 66.5 degrees north, that is, they're above the Arctic Circle, they are always illuminated by sunlight. That is, the day lasts 24 hours. On the other half, here is the Antarctic Circle, with a latitude of 66.5 degrees south. This is latitude is 66.5 degrees north. At the latitudes bigger than 66.5 degrees south, on the day of summer solstice, you can't see the sun. You get 24 hours of darkness. So above the Arctic Circle, you get 24 hours of daylight. Below the Antarctic Circle, you get 24 hours of darkness. Right? And of course, as you move south from the Arctic Circle, you get more and more hours of darkness, but nevertheless, the days are longer than nights. Right? The same in the southern hemisphere. As you move towards the equator at the latitudes less than 66.5 degrees south, you get more and more daylight as you approach the equatorial plane. Now let me just show you one spectacular photograph of what you see over the period of 24 hours on the day of summer solstice while being on the Arctic Circle. This is the day of summer solstice. The sun is always above the horizon, even at midnight. Looking north, you can see that the sun just grazes the horizon. It doesn't fall below the horizon. And then, as after the midnight, it starts coming up. Here is at 6 a.m. It's highest at noon, right? And then it starts coming down, but it's always above the horizon. The daylight is 24 hours long. Okay, so after the vernal equinox, the sun moves above the celestial equator by greater and greater amount, and the maximum elevation above the celestial equator is achieved on the day of summer solstice. And then it starts moving up. Whenever you have an object actually moving very slowly, like if you had a pendulum that is swinging back and forth, at extreme points, it stops and reverses direction, right? So the speed is reduced to 0, and then it's picking up again, okay? So it looks, as it's moving higher and higher, that the speed with which the sun is rising while moving along the ecliptic is reduced, and it looks as if the sun stopped. Hence the name solstice. A similar effect will be on December 22nd, where the sun stops its motion below the celestial equator.